As a team, we did the acceleration laboratory in a simulator, where we could identify 3 different graphs: a position time graph, a velocity time graph, and an acceleration time graph. After finishing the laboratory, we could analyze that the 3 different graphs showed or helped finding different things. So, what are these graphs?
Motion can be represented with a position time graph according to CK12. Position time graphs indicate how far an object has gone from its initial position since it began moving at any given time. In this graph, the velocity of a moving item is represented by the slope, or the steepness. If the slope appears as horizontal, it means that the slope and the velocity are both zero. The position of the item used does not change. When the slope of the line is greater, it can be identified the faster the item motion is changing. Also, according to the physics classroom, in a velocity time graph, the slope of a velocity time graph tells useful information about the acceleration of an object. If the velocity of an object is zero, the slope in the graph will be zero, a horizontal line. But if the acceleration is positive, the slope will be positive as well as an upward going line. The same applies with negative acceleration. If the acceleration is negative, the slope will be to a downward going line. Then, in an acceleration time graph, it can be found a vertical axis. This vertical axis is used to represent the acceleration of any object. In this type of graphs, the slope represents a quantity called jerk, the rate of change of acceleration. Then the area. The area of the graph represents the change in velocity. According to Khan Academy, the area under the acceleration graph for a certain time interval is equal to the change in velocity during that time interval. But how are they different? The position time graph indicates specifically the motion of an item over a period of time. The velocity time graph helps you identify the speed that an object is moving, in other words, the displacement, and if it is descending or ascending, the speed, while the acceleration time graph shows the object's velocity.
The behavior of the simulator in all 3 cases was good. It has options for you to input initial position, initial velocity, and acceleration, while also allowing you to put moving slope and the seconds in slow motion so that you can analyze right away while watching the graph. You can stop the slope from moving at any time you want, since the simulator has a stop button, but you cannot stop the one graph at a time. It's all or nothing. Also, there is an option for showing velocity vector and acceleration vector. The one we used for our lab was velocity vector. The first thing that we noticed on this graph was that the car was really slow and that the velocity was constant since there was no acceleration. So the car was moving at 5 meters per second at all times. And also we calculated that if the car would stop at 8 seconds, the position would be around 50 meters, and since there is no change in acceleration, the velocity would stay 5 meters per second. So this graph is pretty different as the one that we just showed, because this one does have an acceleration and the initial position and velocity are very different from the last one, and the car does move a lot faster than the last one did. For example, it took 0.916 seconds to cross the first little line when the other one took 3 seconds. And the calculated position and velocity for 8 seconds, the position was around 160 meters and the velocity 25 meters per second. This one is also very different as the other two that we just showed, because the initial position was 40, so the car couldn't even cross the first green line, so the little green box just kept going and going and going, and the car did move faster too. So the position and velocity that we calculated for the car moving in 8 seconds, the position is around 190 meters and the velocity around 25 meters per second. The graphs do behave differently within the 3 trials. This is because of the different values in acceleration, initial velocity, and position.